Hi everyone, so today we're going to be doing notes on section 7.8, which is factoring completely. This content isn't actually new, it's just kind of looking at all of the methods that we've learned how to factor so far and putting it all together and being able to look at a problem and recognize which method we're going to use. So go ahead and pause this real quick and write down your steps and then push play when you're ready, to go. All right, so going over the steps, first thing you want to ask yourself is, first and foremost, always ask yourself, is there a GCF? And this GCF could be a constant, which means a number, a variable, which is the letter, or if your A value is negative. So if any of those are present, you're going to factor it out. Then you'll move on to step 2, which is asking, is it a difference of two squares? Now, the reason why I like to do this as the second thing to check is because the difference of squares is really easy to recognize by looking at it. It's only going to be two terms, and then you check if your first and second terms are perfect squares. So that's a really easy thing to check next. If not, then you'll continue on to step 3 and ask yourself, is your A value equal to 1? If it is, you're going to use the big X method. And then lastly, is your A value not equal to 1? So you'll still use the big X method, but then you're going to have that extra step where you divide your two factors by the A value. So let's go ahead and look at some examples. Now again, this is all stuff that you've done before. We're just looking at them all now at one time and recognizing what method we're using. All right, so example 1, 6x squared minus 6x minus 180. So first, is there a GCF? Good, you should have answered yes. There is a GCF of 6 that we can factor out. So let me go to write that. There is a GCF. So we're going to factor out the 6, and then we'll be left with x squared minus x minus 30. Now this thing that we're left with, actually I will do it in a different color. We are going to factor this. So that 6 that we just factored out is just going to stay hanging out at the front. So next thing I'm going to ask, is this a difference of two squares? Good, you should have said no. This has 3 terms, so it cannot be a difference of squares. So this is going to go down to steps 3 and 4. My A value is equal to 1, which means I'm just going to do my big X. The top is my A times C, which is 1 times negative 30. And then the bottom is my B, which is negative 1. Now, what are two numbers that multiply to get the top and add to get the bottom? Good, if you said negative 6 and 5, you are correct. Or 5 and negative 6, it doesn't matter which way you say those. All right, so our final answer, this negative 6 gives us the factor x minus 6, and then the positive 5 gives us the factor x plus 5. Is that my final answer? Good, you should have said no, it's not. We factored out this GCF at the beginning. We have to include it in our final answer as well. Always want to make sure that you don't forget about that GCF. All right, let's look at the second example. So first thing we ask ourselves, is there a GCF? Good, you should have said yes. The GCF is 3. So I'm going to factor out a 3, and I'm going to be left with 1 minus 9x squared. So now I can move on to step 2, because this is now what I'm factoring. So step 2, or question 2, is this a difference of squares? Good, you should have said yes. So it is 2 terms, and they are subtracted, so I want to double check. 1 is a perfect square, and so is 9x squared. So this is a difference of perfect squares. So when I write this, when I'm factoring it, remember this is when we have two factors. One is plus, one is minus. So the square root of my first term, the square root of 1 is, good, you should have said 1. And then the square root of my second term, square root of 9x squared is, good, you should have said 3x. And then again, you want to make sure you don't forget your GCF that got factored out at the beginning. This 3 has to stay hanging out in front when we write our final answer. Oops, sorry, that smeared a little bit. All right, let's look at a couple more examples. So next example, first we ask ourselves, is there a GCF? Good, there is not a GCF per se, but the A value is negative. So A is negative. So we are going to factor that out. So I'm going to have a negative out in front, and then all of my signs are just going to switch. So it'll now be positive x squared, positive 3x, and negative 70. All of the signs switch. Now this thing that's inside of the parentheses, this is what I'm looking at now. So next question, is it a difference of squares? Good, you should have said no. So moving on to steps 3 and 4. My A value is equal to 1, which means I'm just going to use the big X method. So what goes in the top? You should have said negative 70. And what goes in the bottom? You should have said 3. So what are my two numbers going to be? I need two numbers that multiply to get the top and add to get the bottom. If you said 10 and negative 7, you are correct. So when I write my factors, this positive 10 gives me the factor x plus 10. The negative 7 gives me the factor x minus 7. And then this negative that we factored out at the beginning has to stay out in front when we write our final answer. And there we go. Last example that we're going to do together. First question, is there a GCF? Yes, there is. Now I just want to point out, all of the ones that you're going to factor, there won't always be a GCF. But for the sake of having you practice with it more, I did include a GCF on all of our examples we're doing together. All right, so our GCF is 2. And that'll leave me with 5x squared minus 11x plus 2. And now this thing is what we're looking at to factor. Is it a difference of squares? Good, you should have said no. And the A value is not equal to 1, which brings us down to this step 4. So we're going to do the big X, but we need to make sure we divide our factors by the A. All right, so what goes in the top and bottom? Good, you should have said 10 and negative 11. And then my two numbers will be negative 10 and negative 1. But then we have to divide them. Let me get another color. We have to divide them by our A value, which is 5. So negative 10 over 5 simplifies to negative 2. That'll give me the factor x minus 2. And then this one over here, the fraction, the number on the bottom goes in front of the x, and then it's negative, so we are subtracting the number on top. What am I missing? Good, you should have said the GCF or the 2 out in front, something along those lines. Sorry if that noise was kind of loud. I closed my pen by just pressing it down, and I didn't expect it to be that loud. All right. I want you to try the next two problems on your own. So go ahead and push pause, and then when you're ready to check your work, press play. Go ahead and check your answers to these last two problems. I want to point out that the first example had a GCF and your A value was negative, so you should have factored out a -2. And then what was left inside the parentheses that you factor your A value was equal to 1. Versus the second example, there was no GCF and no negative A value, so you just went ahead and factored it using your big X, and your A value was equal to 7. Actually, let me draw a little arrow to that. So you needed to divide both of your factors by 7, and that would be your answer. I also drew over here off to the side because 56 and -18 may be a little bit harder to see up front what your two numbers are. So just a friendly reminder, writing your possible factors over off to the side is always a super helpful way to figure out your numbers when it's not really easy to see right away. Alrighty, that is the end of your notes. Have a good rest of your day.